In today's session, we are going to talk about the application of critical path method to estimate the project completion time. For that matter, we took this example, which is a project represented in 3 columns. Activities are represented in first column, predecessor association is represented in second column, and duration in the third column. The duration, let's take its unit in days. So this means activity A can be completed in 2 days, activity B in 1 day, and similarly, so on and so forth, activity L in 4 days. We are supposed to use one of the software, which is called TORA's Operations Research Algorithm, to estimate the project completion time. And more specifically, we are supposed to identify the critical path for this particular project. Now, the first step in order to do this, we are supposed to transform this information into one of the network diagrams using activity on arc. What is activity on arc? I recorded a session concerning activity on arc, so you may watch that and understand the specifics of activity on arc. However, in this session, I am going to proceed by representing this particular project in activity on arc without explanation. So activity A and B, they do not have any predecessor. So this means they can logically start from a single node. So this is node 1, node 2, that is activity A, and node 3, this is activity B. Activity C can only start when activity A is completed. So logically, it should end at node 4th. Similarly, activity D can only start when activity B is completed, but keeping in mind that activity C and D are the predecessor of activity F. So this means C and D are supposed to end at the same node. So here you go, that is activity D. So C and D, they are ending at node 4. Moreover, activity E can only start when activity B is completed. So this means it should end at node 5. That is activity E. Activity F can only start when activity C and D are completed. So activity C and D are completed at node 4. So here you go. This is activity F, and that is node 6. So activity F starts from node 4 and ends at 6. Now, G can only start when activity E is completed. So here you go. That is on another arc, which is ending at node 7, and we'll call that activity G. Similarly, activity H can only start when E is completed. So this means activity H will also start from node 5th and end at node 8. So that is activity H. Activity I can start when activity G is completed. So this means we are supposed to extend that towards node 9, and I'll call that as a activity I. But remember, activity I and J are supposed to end at the same node since they are the predecessor of activity K. So the node at which activity I is ending, that is node 9. Activity J should also end at that, and activity J can only start when activity H is completed. So here you go, that is activity J. Second last, activity K can only start when activity J and I are completed. So we'll extend one another arc and we'll end it at node 10, and we'll call that K. And lastly, activity L can only start when activity F is completed. So here you go, your network diagram is completed. And this type of a network diagram is what we call activity on arc. So here the tasks or activities are represented on arrows, and the nodes are either the starting point or finishing point of a particular activity in a project. Now we're supposed to use this information, and we'll put that information in TORA's Operations Research Algorithm, and we are supposed to estimate the project completion time and the critical path for this particular project. Now, this is TORA's Operations Research Algorithm. If we click right here, we have several modules to choose from. So we are going to choose the project planning, that is critical path method. I'll go to the input screen and we'll give it a title. So let's suppose that is a project 0. And after you enter a title, you'll get a table. You're supposed to enter some information in it. So there were activities ranging from activity A till L. So if we represent this information right here, activity A starts from node 1 and ends at node 2. So I'm going to write something like this, 1 and 2, and I'll give it task A. And what's the duration of that? The duration of task A is about 2 days now. So I'm going to write 2 here. Similarly, node 1 and 3 represents task B, and the duration of which is about 1 day, right? So I'm going to write 1 here. Similarly, task C starts from 2 and ends at 4. So I'm going to write here 2 and 4, and I'll write here C. And the duration of task C is about 3 days. So I'm going to write 3 here. Similarly, task D starts from node 3 and ends at 4. So I'm going to write here 3 and 4. That is task D. And the duration of which is about 4 days. There you go. Similarly, task E starts from node 3 and ends at node 5. So 3 and 5. And that is task E, the duration of which is about 3 days. So I'm going to write 3 here. Followed by activity F, which starts from 4 and ends at 6 node. So 4 and 6. And that is activity F. And the duration of activity F is about 2 days. Similarly, the next activity is activity G. Activity G starts from node 5th and ends at 7. So 5 and 7. And that is activity G. And activity G is completed in 5 days. Similarly, activity H starts from node 5th and ends at 8. So I'll write here 5 and 8. And that is activity H. And activity H can be completed in about 3 days. Activity I starts from node 7 and ends at 9. So 7 and 9, and I'll call that activity I. And the duration of activity I is about 1. Followed by activity J. Activity J starts from node 8 and ends at 9. And the completion period of J is about 2 days. Second last, that is activity K. Activity K starts from node 9 and ends at 10. So 9 and 10. And that is activity K. And lastly, and the duration of activity K is about 3. Lastly, activity L starts from node 8 and ends at 10. So I'll write here 6 and 10, and I'll call that activity L. And the completion time for activity L is about 4. Now, we arranged all this information in this table. All we need to do is click on solve and solve the problem and go to the output screen. And we are supposed to click on CPM calculations. And when we click on CPM calculation, we are supposed to click all steps. And here we got about 4 tables. And in that 4 table, the most important one is this time period right here, which is about 13 days, since the unit of time which we used is in days. So this means that this particular project can be executed in 13 days. Now, the most important thing in which critical path method actually identifies, it's the critical path. So the critical path in this particular case is activity B, E, G, I, and K. So if we represent that activity B, E, G, I, and K, it's a critical path. So all tasks represented on critical paths are the activities of a project in which we are supposed to be careful. These activities are supposed to start on time. Slight delay in these activities can cause the project completion time to extend beyond the one which is represented right here. And that is the end of the representation of critical path method through a software that is called TORA Operations Research Algorithm.